This is the lab demo for Lab 4. What we need to do is open the normal distribution calculator by clicking Stat, Calculators, and Normal. This looks a little like the binomial distribution calculator. We'll need to type in the mean and standard deviation, which is of course defaulted to the standard normal distribution with a mean of 0 and standard deviation of 1. Now we can also select less than or equal to or greater than or equal to. And these of course don't include the strict inequality options because in a continuous distribution like this, strict inequality is the same as inclusive inequality. So we only get two options here. And the x value, which would represent the cutoff value for the area under the curve, would be typed in here, and then we have of course the probability, which is typically what we're calculating. The area under the curve is the same as the probability, and so the calculator will calculate either or. Now we can also type in the probability and calculate the x value. We also have the between option, which essentially does the same thing, but of course we type in a lower bound and upper bound for that one. So let's try a mean of 50 and a standard deviation of 7, and we'll compute the probability that x is greater than or equal to 65. You can use enter or click compute, and of course we see that probability is 0.0160. If we want the complement or the left tail value, you could switch this to less than or equal to, and of course we get 1 minus that previous value here. Another important skill is calculating z alpha. Now when we calculate z alpha, we're specifically talking about the standard normal distribution with a mean of 0 and a standard deviation of 1. When we calculate z alpha, we're considering the right tail area. So for example, z.02 is asking you to calculate the z-score that cuts off a right tail area. Hence I've selected the right tail area greater than or equal to. And I'm going to type in an area of 0.02. So the probability or the area under the curve would be 0.02. And we're looking for a right tail area. Compute, and we see that z.02, in other words, the z-score that cuts off a right tail area of 0.02 is 2.537. Excuse me, 2.0537. In contrast to calculating z alpha values, calculating for percentiles is slightly different. When working with percentiles, we work with the left tail area. So if we type in a mean of 50 and a standard deviation of 7 again, we can calculate the 80th percentile by typing in 0.80 for the area under the curve or the probability and selecting left tail area. The 80th percentile cuts off the bottom 80% or the bottom cuts off an area of 0.80 in the left tail. So in this case, the 80th percentile, in other words, the value that is greater than 80% of values in the distribution, would be 55.89. Here's another important trick. When we're working with sampling distributions, it's important to note that we need to make some additional calculations for the parameters to our distribution here. When we're looking at the sampling distribution of the sampling mean, we'll be dividing the standard deviation by the square root of the sample size. So for example, if we have a sample of size, let's say 40, we would divide 7 by the square root, SQRT, and then use parentheses around 40. SQRT with 40 in parentheses is the square root of 40. So we're actually doing this calculation right here in the field of the normal distribution calculator. And then of course we can calculate the probability that the sample mean satisfies certain requirements. So let's take a look at the probability that x is greater than or equal to 51. So what we see is the probability that the sample mean is greater than or equal to 51 is actually 0.1831 approximately. When working with the sampling distribution of a sample proportion, the standard deviation is calculated using a slightly more complex expression, so it might be wise to calculate that aside and round to 4 or 5 decimal places and type it in here in the calculator. It can be done this same way, but it's not very practical and it's difficult to see if you have parentheses in the right locations. Well, that should be everything you need for Lab 4. If you have additional questions, please ask. You can also look for additional YouTube videos on StatCrunch or watch the StatCrunch videos associated with the examples in sections 7.2, 8.1, and 8.2. Don't forget about the technology step-by-step as well.